So, hello everyone, let's start our session. So, as you all know, yesterday we have read something about periodic table. We have started periodic table basics. Periodic table basics. So today what we will learn is, we will move to little bit classification of elements, that how elements are classified into different elements, different types, okay. And apart from that, we will see how metals, non-metals and metalloids are classified, okay. These two things we will see in the today's lecture. So let us start. So let's see what, let's think about a little bit what yesterday we have seen. We have seen that periodic table is classified into 4 blocks. One is known as S block, one is known as P block, one is known as D block, and one is known as F block. All of us know about this, that S block is what? That wherever electrons, last electron enter into S sub shell or S orbital. In P type of or P block, what happens is last electron enters into P subshell. Apart from that, similar to that, in D kind of or D block, what happens is last electron enters into D subshell, and in F block, what happens is the last electron enters into F subshell. One more thing we got to know is that in D subshell and F subshell cases, or we can say D block and F block cases, what used to happen was that the last electron was not entering in the outermost shell, but in case of D, it was entering in one after last, and in case of F, 2 after last. First of all, this one after last was called penultimate, and this 2 after last was called anti-penultimate. So these were the two things that we got to know, okay. So let us move to today's topic and what we have to know today. Till here, up to last yesterday's lecture, if somebody has any kind of doubt, you can ask. Okay, let us move. First of all, let me give you a small question. There is an element and its name is zinc. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, or directly we can write it what? Argon 18, 4s2, 3d10. Just tell me in which block it will belong. Right answer fast. In which block it will belong? This Zn or zinc? Please write answer fast. D. Shrikar. Very good. D. Yeah. Revati. Swapna. Very good. Solo. Kaushal. Very good. Shriya. Tushar. Ramalakshman. Okay. Very good. So, can anybody tell me why it is considered into D block? What is the reason? What is the reason for this lying in 2D block? Tell me. Anybody who can tell? Last electron in D orbital. Very good, Venkat. General, yeah, from general configuration also. Very good. Very good. Okay. So two things are there. First, last electron is entering into D orbital. Apart from that, see, it is ns2 n-1 D and 1 to 10. And this is the general configuration of D block. All of us know. Very, very good. So very good, this you got very easily. Let us move to next. Now let us think about the classification of elements, or to be more precise, no, don't write it classification, instead we write types of elements. So basically there are some types. First one is known as noble gas, then comes second one, third one and fourth one. Second one is known as representative elements. Then third one is known as transition elements. And then fourth one is known as inner transition elements. Some of them we have discussed already. Inner transition. Some of them we have already discussed. Now let us move and think about them one by one. So all of us know that noble gas is what? Those elements which belong to 18th group, group 18. Apart from that, what is their general configuration? So it is NH2 NP6, that means they have a completely filled shell. Why they are considered noble gas? Because they do not react with anyone very easily. So let us think about noble gas. First one, noble gas. So what we get to know about these? First of all, it is group 18 elements. Is it okay? Now they belongs to group 18, and what is their general configuration? General configuration is NS2 NP6. Is it okay? Now similar to that, if you think about something more, they are very, very less reactive. And why they are very, very less reactive? Because they have complete octet. And complete octet means their valency is 0. They do not require anyone to combine, okay, to complete their valency. Their octet is already completed. This is all about noble gases that you have to know. There are too much, but for at this level we have to stop here only. Okay, till here if anybody has any kind of doubt, tell me. Then I will tell you what are the examples. Satisfy the octet configuration rule, yeah. Helium, obviously for helium what we have to say? For hydrogen and helium we will discuss duplet always. Okay. Anybody else? Yeah, for helium NH2, that we will see. When we will write the cases one by one, there we will see. Okay, let's move. Let us think about the members of these noble gases. These are helium, neon, argon, krypton, xenon and radon. There is no need to study this as this is a radioactive element. So helium is what? 1s2. For these kind of elements, duplet is complete. This is the case of duplet, and for other all of them, octet is complete. Duplet means in outermost, if outermost subshell is S, it has 2 electrons, then duplet is complete. That is only valid for hydrogen and helium. For neon, it is 2s2, 2p6. Before configurations you can write by your own, 1s2 and all, okay. And for AR, it is 3s2, 3p6. Before configurations you can write. Krypton, it is 4s2 4p6, and for xenon 5s2 5p6, and for radon 6s2 6p6. That is the thing. See, for all of them octet, that means in last shell there are 8 electrons, and that is already completed for all of them. Okay, so that kind of things are there. This is the basic configuration of all the noble gases. Now let us move to the next one, that is representative elements. Representative elements. Now, what are representative elements? So, all S block plus P block except noble gases. All S block plus P block except noble gases, that is known as representative elements. This kind of elements are called as representative elements. Now, if anybody tell you that, what you have to do is just check out that whether this kind of atom or the given element belongs to S block or P block. If it belongs to S block or P block and it is not a noble gas, then directly and very easily you can say that this is a part of representative elements. Think about, let us think of phosphorus. Okay, atomic number is 15, 1s2 2s2 2p 6 3s2 3p3. That's it. This is the configuration, or in other way you can write it, neon 10 3s2 3p3. That is also a way. Now tell me, first of all, in which block it will lie? Write fast. In which block it will lie? P. Kaushal, Shrikar, very good. Revati, Sanjana, very good. Shriya, Swapna, very good. Jitendra, Shriya, Usha, very good. Okay, so P. And why P? Because last electron is coming into P subshell. You can directly see that last electron is coming into P subshell or a P orbital. That's why it is a part of P block. So it is a part of P block. Tell me whether it is a noble gas. Whether it is a noble gas. Tell me. Write fast. No. Very good. Yes, Satvik, how? No. Very good. No. Yeah. Very good. So, what we can say is it is not a noble gas. Not noble gas. So, what we can say, those elements which belongs to either S block or P block except noble gas are considered as representative elements. So, can I say that phosphorus is a representative element? Representative element. Is it okay? Now, let me give you some more questions, some more examples, okay? And then you will find out whether they are from representative elements or not. Think about. Now let's move and let me give you sulfur atomic number 16, chlorine atomic number 17, scandium atomic number 21. Apart from that, let us write calcium atomic number 20, then comes cobalt atomic number 27, then comes argon atomic number 18. Tell me, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Tell me, question, how many of given elements belong to or belongs to representative elements? Tell me, representative elements. Tell me, how many of these belongs to representative elements? Do it fast. Three, five. Okay, please write the name also, that who are the part of representative elements. Five. Not at all. 5 is not answer. First, second, fourth. Okay. See, what you have to do is, so what we have to do, write electronic configuration. This will be neon 10 and then 3s2 3p4. This will be neon 10 3s2 3p5. This will be argon 18, then 4s2 3d1. This is also argon 18 4s2. This is argon 18 4s2 3d7, and this is argon 18. That means, what is the meaning of argon 18? 1s2 2s2 2p6 3s2 3p6. Now very easily you can tell, last electron in p block, it is d block, cancel. S block, this d block, cancel. This p block, but p block fully filled, that means noble gas. So this is also cancelled. So how many are correct? First is correct. Apart from that, second is correct and fourth is correct. These are the three things or three elements out of these which are the part of representative elements. Is there any kind of doubt anybody has? You can ask. 1, 2, 4. Yeah, correct. Those who are giving 1, 2, 4, correct, actually correct. Is it okay? Now, let us move to next part, and this is what? Transition elements. This is a very, very important part. Transition elements. So, first of all, if you see, this is the periodic table, and in this you can see that this part represents S block and this part represents P block. Is it okay? And when you are moving from S block to P block, during this, in a transition, you will meet these guys, and these guys are known as transition elements. Transition elements, and you know, there are some guys which are here marked as star and written below. These lies inside these transition elements. That's why they are known as inner transition elements. So first we will talk about transition elements, then we will talk about inner transition elements. Okay, that's it. Let us talk about transition elements. First of all, we get to know, because they came in between the way when we are moving from S block to P block, they are coming in between. That's why they are considered as, or they are called as, transition elements. Is it okay? I think this is very easy thing. This also I have told yesterday. One more thing, what you can say is all the D block elements are transition elements. So you have to know that if someone is lying in D block, then only it will be considered as a transition element. Let me give you some examples. If you think about, there is an example that is, let us say, think nickel, that is 28. What is the configuration? It will be Ar18 3s2, sorry, opposite I have written, it is 4s2 and 3d8. Is it okay? Similar to that, if you try to write palladium, that is its larger friend, and it is also same, and it will be krypton along with 5s2 and 4d8, or to be more precise, let me tell you what is the reality. Actually it is 4s0, sorry 5s0, 4d10 kind of thing, and then platinum is there, that is xenon along with 6s1 and 5d9, that kind of thing. These are the three systems, that is a electronic configuration that you have to know. What you can tell about this is which block they belong to. Tell me. Think about this, that in which block they will lie? All of them. D block, okay, D, D block, D block, very good, D block, D, okay. That means they belong to D block, and you know all the D block elements are considered as transition elements. It is already told to you that they are called transition elements. So can I say that all of them are transition elements? Say yes or no? Transition elements. So all of them are considered as transition elements. Is it okay? So this is the thing. So till here, if anybody has any kind of doubt, then you can ask me. Is there any trick for finding electronic configuration? There is no trick. There is a specific formula also. There is a specific method, that is filling of atomic orbitals or finding electronic configuration. That is applying Aufbau's principle, Pauli's exclusion principle, and Hund's rule. There are three things. I think Kaushal, you have got the answer. Okay. Now, let me tell you one more small thing when we are here. There is an element, there are two elements, zinc, cadmium and mercury. Three elements actually, not two. What we have to know about this is, their configuration is, last configuration 4s2, 3d10, then apart from that, this is also 5s2, five s2, 4d10 and 6s2, 5d10. These three elements in which last electron is getting added to d block, or we can say d orbitals. But the thing is, they are not considered as transition elements, because they do not show the behaviors of transition elements like other transition elements. What are the behavior, you will get to know just in a short while. I will tell you. Okay, so they are not considered as transition elements. Apart from that, their last electron is getting added to d orbital. That's why they are part of d block still they are part of d block, but they are not transition elements. So if somebody asks you, are there some elements which are part of d block but are not considered as transition elements, so always you have to name zinc, cadmium and mercury. This is group 12 elements. These are group 12. You have to know group 12. Okay, so group 12 elements, 3 are there. These are not considered as transition element despite they are part of a d block. Okay, so till here, if anybody has any doubt, you can ask. Pseudo inert configuration, very good. You will get to know, you will meet pseudo inert configuration somewhere in the period, somewhere in the chemical bonding. For PD, why 5s0 4d10, not 5s2 4d10? How 5s2 4d10? If you think about, that number will not belong to PD. That number is something else. That number actually belongs to CD. If you try to fill up to 5s2 4d10 following the Aufbau's principle, you will get to know. Will you explain those three principles that are explained in the regular classes, that are not the part of bridge course? Sir, is it pseudo inert gas configuration? Yeah, it is, but what it is, I will tell later, not now. Yeah, pseudo inert gas configuration. Very good. Okay, let's move and let us talk about the inner transition elements. Before that, some more things about. Wait a minute, please. If there is still some doubt, you can ask. Then we will move. let's move. Now let us move to characteristics of transition elements. Characteristics of transition elements. Let us move to the characteristics and let me tell you some characteristics. First of all, they show variable oxidation state. They show variable oxidation state. Fe, atomic number 26. Configuration AR18 4s2 3d6. Everybody know it is D block. Apart from that, their D is not completely filled, so they are also transition elements. They are also transition elements or transition element. Okay, so what happens is this Fe can show two states, that is Fe plus 2 and Fe plus 3. And if you have read earlier lectures, you might be knowing what is this Fe plus 2 called. Please name it. Please name what is Fe plus 2 called. Let's see how many guys remember last lecture, means previous lectures. Sai Satvik, good. Shrikar, very good. Okay, Ferrous, everybody. Very good. Ferrous, okay. So Fe plus 2 is known as ferrous and Fe plus 3 is known as Fe plus 2 is known as ferrous and Fe plus 3 is known as ferric. Very good. Less means us and more means ik. So ferric. And if you notice the colors that I have used, if you see, for ferrous I have used green color and for ferric I have used red color. So always remember, these are also important thing, that Fe plus 2 is green colored and Fe plus 3 is red colored, or to be more precise, it is blood red color. It is blood red color. Blood also got its red color due to Fe plus 3. Okay, so ferrous is green colored and ferric is red colored. So this is how we get to know that variable oxidation states. For other things also, there are other elements also which show variable oxidation states. For example, nickel, that is Ni2 plus and Ni4 plus. Similar to that, copper plus and copper 2 plus. So these kind of things are there, variable oxidation state. Apart from that, what are other properties? So they show catalytic properties. Catalytic properties. That means they can be used as catalyst. And you know catalyst is what? That can alter or that can change the rate of reaction. That can either make a reaction fast or can make a reaction slow also. Not always catalyst will make fast. It can also make the reaction slow. So catalyst, I am writing, means make reaction fast or slow. It can change the rate, change the speed of the reaction. Apart from that, they are usually paramagnetic. Paramagnetic means they are attracted by external magnetic field. If external magnetic field is there and there it is some D block element is there, it will be attracted by it. And some of them are very highly paramagnetic. They are called ferromagnetic, like cobalt, nickel, iron. kind of these things. Okay, these are very highly paramagnetic, that they are called as ferromagnetic. There is a specific category of ferromagnetic, that they are very highly attracted towards the external magnetic field. Apart from that, they forms colored ions. They form colored ions, as you have already seen that Fe plus 2 is green colored, Fe plus 3 is blood red colored. So their ions are usually colored. Okay, these kind of things are there. Apart from that, if you see what else is there, so paramagnetic they are, catalytic behaviors, colored ions, I think everything is covered. Okay, that's it. That are the normal good properties or normal important properties about transition elements. Let us move to the next, and let us talk about inner transition elements. Inner transition elements. So inner transition elements, which are there, let me show you. So these are inner transition elements, that means F block elements, all of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 these and 14 these, how many? Total is 28. 28 elements are considered as inner transition elements. What we can say about this? That all of them lie in group 3. Apart from that, their period is 6th. If you see, this is 6th period, 1st, 2nd, 3rd, 4th, 5th, 6th and 7th. This is 6th and 7th. So they are part of 6th and 7th period. Okay. Apart from that, what we can say else is that their general configuration is NS2 N-1 D 0 to 1 and N-2 F 1 to 14. These kind of general configurations are there. Okay, so their F block will lie, or their F block will contain the last electron, that's why they are considered as F block elements. Apart from that, what we can say is that most of the nuclear fuels and radioactive elements belong to this category, belongs to this category. This is the category in which most of the nuclear fuels and the radioactive elements belong. For example, you might have heard about uranium, you might have heard about thorium, you might have heard about europium, all of these kind of things. Okay, think about this. See, uranium is where, see, uranium is here. Okay, thorium is here, that kind of things. Okay, and europium is here, these kind of things are there. Okay, so most of the elements which are used in nuclear energy, or those are used in nuclear bombs, or that are used in different kind of radioactive elements, those all belongs here. So this is all about the representative elements, inert gases, noble gases, means the same thing. One more thing, let me write it here. Noble gases, also known as inert gases, means the same thing. Inert means very less reactive. Okay, so noble gases done, representative elements done, transition elements done, and inner transition elements done. If anybody want to ask anything, you can ask. Okay, I think there are no doubts. Okay, so I think today we have learned about types of elements. Tomorrow we will continue some metals, non-metals and metalloids kind of things. Okay, and that's it for today. I hope you enjoyed the class. That's it for today. We'll meet in the next class. Thank you.